Hi all. In this video, we will discuss about the importance of creational design pattern and details like definition, purpose, and usage. This video can also be considered as a quick overview of creational design patterns. We have created separate videos for each of them describing those patterns in detail with code demonstration for better understanding. Also, we have included interview question and quiz which will be helpful for better preparation for interviews for Java architect or application architect. Now let's see what are creational design patterns. Creational design patterns are a category of design patterns that deal with object creation mechanisms. They aim to create objects in a manner suitable to situation, providing a way to decouple your code from specific classes and their instances. These patterns help make a system independent of how its objects are created, composed, and represented. Now let's see what are the importance of creational design patterns. They enhance flexibility by abstracting the instantiation process, making it easier to manage and extend code. They also promote code reusability by defining clear structure for object creation. Moreover, these patterns help to control the creation process, which is crucial for complex systems where object creation isn't straightforward. Now let's see what are the various design patterns. The first one is Singleton design pattern. It ensures a class only has one instance and provides a global point of access to it. The purpose of Singleton design pattern is that it restricts the instantiation of class to one single instance. This is useful when exactly one object is needed to coordinate action between the systems. A typical usage is a configuration manager in software application that needs to be accessed by various components. Second is factory method pattern. A factory method pattern is a pattern which defines an interface for creation of object but let subclasses decide which class to instantiate. Factory method lets a class defer instantiation to subclass. The primary purpose is it provides a way to delegate the instantiation logic to subclasses, promoting loose coupling by eliminating the need to specify the exact class of that object that will be created. A typical example is an document editor application that can create different type of document, example, text, spreadsheet, presentation based on user input. Third is abstract factory pattern. This provides an interface for creating families or related dependent objects without specifying their concrete classes. The abstract factory pattern works around a super factory which creates another factory. It provides a way to encapsulate a group of individual factories that have a common theme without specifying their concrete classes. An example can be a GUI tool that supports multiple look and feel standards, for example, Windows, Mac OS, or Linux. Next pattern is builder pattern. It separates the construction of complex objects from its representation so that the same construction process can create different representations. The builder pattern constructs a complex object step by step and allows the construction process to be more controlled and customized. And the code for construction and representation. An example can be a meal ordering system that builds a meal with various items like main course, drink, dessert based on customer choice. Finally, we have prototype pattern. This specifies the kind of object to create using prototypical instance and create new objects by copying its prototype. The prototype pattern is used to create a new object by copying an existing object known as prototype. This pattern is used when the type of objects to create is determined by a prototypical instance which is cloned to produce new object. A typical example can be a game where uses a prototype pattern to clone characters with similar attributes rather than creating each character from scratch. That is all in this video. Check out detailed video for each of these discussed design patterns. Thank you.